In this video, we'll be taking a journey through the Data Productivity Cloud Designer. We'll learn to load data, transform it, and schedule those pipelines to run automatically, and even use AI to augment our work. We encourage you to follow along yourself and take your time in learning each part of the product. In the following example, we'll look at a simple case where we have some data sets from our social media platform, and we want to load these into a data warehouse and transform them to become more useful. But before that, let's review how to get started with the Data Productivity Cloud. Begin by going to hub.matillion.com to sign up for a user account. Your account gives you access to all Data Productivity Cloud accounts and projects you've been invited to. You'll receive a confirmation email. Click Activate Account, and we're on our way. Enter your personal information, and this will begin to spin up your account. Then you need to enter the region for your account. Be aware the region can't be changed after selection. Okay, next we need to select a data platform. The Data Productivity Cloud can extract and load data from various sources, whether that's an on-premises source or Internet as a service. This data warehouse is where you will load your data to, ready for transformation. The Data Productivity Cloud uses push-down transformation logic to the warehouse, using the computing power of the warehouse to perform the transformation of your data. To connect to your existing data, you can connect to your Snowflake, Redshift, or Databricks warehouse. Or if you're starting from scratch, you can use a Matillion trial warehouse, and this is what we'll do in this example. Okay, click Continue and your trial warehouse will be created. When this is all set up, you'll be loaded into your first project in the Data Productivity Cloud. A project is a collection of assets that all come together to help extract, load, and transform your data. Included is a set of test data called GreenWave, and opening the GreenWave's pipeline folder will reveal a set of test pipelines that use this data, which we can open up by double-clicking on it. Each pipeline is separated into tabs once opened. A pipeline is a set of components that are linked together with a flow. Each component performs a single task, and you can see the order they run in by following the arrows going across the workspace. This workspace is called the canvas. When running, pipeline components are triggered one by one, and then they move to the next. Okay, so that's enough of looking at the demo. Let's make our first pipeline of our own. First, I'll close these open tabs just to neaten up the workspace. Then click the Add button to add a new folder. As this is for our social media data pipelines, let's call this folder Social Media Data. So there are two types of pipelines that you can create on the Data Productivity Cloud: Orchestration and Transformation. Orchestration is for extracting and loading data into a data warehouse. Transformation pipelines are for transforming that data while it's in the data warehouse. As we haven't loaded any data yet and our data is still in its source systems, let's first create an orchestration pipeline so that we can load our social media data. And we'll name this pipeline Social Media Data. Once the pipeline is created, we'll have a new canvas to begin working on. On the canvas, by default, is a Start component. This is where your pipeline flow will begin. Clicking on the component will open up the component's configuration panel. The plus icon on the canvas is where you can add your first component. Click this and you'll be presented with a list of components to choose from, organized by category. We'll start by typing in Excel, so we can load our social media data from an Excel sheet, which is stored in an S3 bucket. Once the component is on the canvas, by clicking on our new component, you can see that we have all the configuration options here. With this and all query components, we need to connect to a data source, configure the data, and then choose a destination for that data to go into. The destination is always a table on the target data warehouse. Let's start with the connect section of the component properties. And we're going to use a storage type of S3, as that's where our Excel file is stored. And I will paste in the S3 location for this file. If you'd like to follow along, a link to the file will be in the video description. So here's my file in the S3 bucket. Don't worry if you see an error here. It's saying it doesn't have access to explore the buckets based on our credentials. But as for this example, we're using a public file, we don't need those credentials. After we've pasted that in, you can see here the green tick means that the connection section has validated successfully and has no errors. Now let's open up the configuration section. The options highlighted in red are required fields. Whilst there are other optional fields here, we'll focus on the highlighted sections so that we can load our data. Let's begin with our data source selection. Expanding this selection, we can see two worksheets from the Excel file, one for users and one for posts. Here we'll select posts. Under the data selection, you will choose which columns from the sheet to load. For this example, we'll select all. The green tick at the top of the configuration section again means that this section is now validated. Now we need to configure the destination options. By default, the warehouse, database and schema will be set to an environment default, which was automatically set when we opted to use a trial warehouse. These options can be changed in the project menu, but for this example, we're happy with our automatic defaults for now. So now we need to enter a name for the table to be loaded to, and we'll call this table posts. As a table of this name does not already exist, the component will create a table in our data warehouse, with data types for the columns taken from the data source. Next, we need to choose a staging platform for the data to be staged before loading to our data warehouse. This defaults to Amazon S3, which requires you to use Amazon credentials to access. Since the trial warehouse is a Snowflake warehouse, we'll change this to Snowflake Managed, which makes our lives a little easier as we won't need to add any additional credentials. Now you'll notice we have all green indicators next to all the sections in the component properties, and this means it's fully validated and ready to run. Validation can be run manually at any time by clicking the Validate button, as a way of checking for errors before running your pipeline. Another thing we can do before running our pipeline is sample our data by selecting a component, then using the Sample tab and clicking Sample Data. Here we can check the data directly from the Excel sheet before loading it into our warehouse. You can see this is our post data with the expected columns, including likes for each post and the user ID for the post. Okay, so now we've got our first data source. Now it's time to load our second sheet of data. But the issue here is that the data is stored in a Google Sheet rather than an Excel file. But that's okay, because instead of adding another Excel query component to the canvas, instead we'll select a Google Sheets query component. If you want to follow along with this example, visit the share link in the description to view the dataset. You can then add it as a shared file to your Google account. Just make sure you copy it to the account that you'll want to access through the Data Productivity Cloud. So now we'll use the Data Productivity Cloud to bring these two sources of data together. We'll need to connect to Google to access this Google Sheet. Now, different connectors will use different methods of authentication, depending on how the service prefers to handle it. For Google Sheets, we'll need to set up an authentication to our Google account. Click on Authentication in the component properties. If you have already set up an OAuth for Google Sheets, it would appear here. As we're creating a new one, we'll click on Manage. And this will take us back to our main project screen. And here we can see just a few of the assets we mentioned before. Projects have branches for version control. Environments define your project's connection to the data warehouse. Secret definitions are used to securely store sensitive details such as passwords. Cloud credentials can give you access to cloud platforms such as Amazon Web Services or Microsoft Azure. You can use schedules to run pipelines automatically, and you can control access to this project for your team. But right now we're interested in accessing our Google Sheet. which means we need to add a new OAuth by clicking on the OAuth tab. And we're going to call that Google Sheets, and choose the provider of Google. We'll also use a 2.0 authorization grant, and then select the correct Google account associated with the sheet that we've just copied that you will need access to. Then click Accept. Now we're authorized with your account, our new OAuth will be in the OAuth section. Let's navigate back to branches and back into our main branch. Then into our orchestration pipeline. Okay, so now we are back on the canvas. Let's click again on the Google Sheets query and go to authentication. Now we can see the OAuth we've created can be selected. Let's move to the configuration section and choose our data source. The name of the sheet with the data in is called user data. We'll bring in all the columns using the data selection property. As an optional extra, we're going to increase the limit to 1000, as I know the file has 1000 users in it. You can also remove any value from this property and it will load the entire data source. Let's choose a name for the target table the user data will be loaded into. To keep it simple, we'll call this users. And just like before, we're going to make this Snowflake managed. We can see we have all green validation ticks in the component, so let's sample the data before we run the pipeline. And in our users table, you can see we've got user ID, we've got usernames, and the country they came from. All the data looks good to me, so we're ready to run the pipeline. Let's click Run. This pipeline will pull data from these two data sources and load them into their respective tables in our data warehouse. You can see with the task history panel that's popped up, it's validated and run successfully. This task history will also show any other previously run pipelines. Right, so now we have our data, it's time to transform it. To do this, we need to create a transformation pipeline, and we're going to call this Join Datasets. Now we have a new empty transformation pipeline, which lets us use special transformation components to affect our data. The first thing we want to do is to pull our data into the pipeline, so we can start working on it. Let's add a new component. Click Read here on the categories so we can see our different read component options. If we read the description of our components, we can think, well, we've already got our tables and we need to read data from them. So we'll use a table input component. Open up the properties and add in the first of our tables under the target table. We've already got posts and user tables here because we ran our orchestration job and created these tables. So let's choose the first of those tables, posts. Another good way of checking what tables we have available to us is if we go to schemas on the left-hand side. You can check what tables exist in your schema. So if you're making new tables, you can check whether they already exist here. Let's finish configuring our table input component, where we're going to pull in every column name. Then let's repeat the process for our table of user data. We can also sample the data directly from the component before performing any transformations. So let's perform our first transformation to clean up our data a little bit. You may notice the user ID in the posts table has a decimal place, where the user ID in the users table doesn't. This is due to us pulling two different data sources that handle data differently to one another. So we're going to use the convert type component to change the float data type for this column in the posts table into a number. Add a convert type component to the canvas and open up its properties. Select the column and change it to its new data type. While we're here, let's change the likes column as well, because that should also be a number. Now, if we sample the data from the convert type component, you can see the effect the component has had on the data. So you can now see the user ID is a number, not a float. Now we're ready to connect this all together. To recap, we have two datasets. One has data on post titles, authors, and likes. The other set has user data with names and locations. We'd like to use a single dataset so we can see the names of each post author and where they come from. And luckily, we can join the two datasets by using their user IDs to do exactly that. Let's add a new component, which will be the join component. This is doing a regular SQL join, which means we need multiple data sources to join together. So let's also drag a connection from the users table. Now both of these data sources are going into the join component. Let's choose our main table data source, and you'll notice under the data sources it's recognizing the components that are connected to the join rather than the tables. As you can see, the data source includes the convert type component and the users table, and not the posts table. This is because the join component is connected to the convert type component, and means that we're joining to the transformed data, not the original untransformed data. For the main table, we'll select convert type as we want to join the transformed data, but we'll give it an alias of posts so it's easier to identify what this data is. Now let's click into joins, where we can join to the users table. We're going to keep the alias of users for this, and for the join type, we'll use an inner join, as we're happy to discard posts without valid author records. Next up, we're going to create our join expression. So down here, you can see all of the incoming columns and the different data sources they come from. So here we've got users and posts. We'll join the posts user ID with the users user ID. Click the plus button while hovering over the posts.userid column to add it to the expression. Or we can also type it in if we choose. Enter an equal symbol and then let's add the user ID from the user's source. In effect, we're joining our two tables on the knowledge that the user IDs are a column element with the same meaning in each dataset. Under column mappings, we choose what data we want this join to output. Let's click Add All Columns so we can see what we're working with. Here is a good opportunity to do a little bit of cleaning up. So let's say, for example, we don't need the row IDs, the post IDs, or the user IDs. As for our analysis, we only need the usernames. Let's use the columns that make our data clear and readable. Click Save, and now again let's sample the data. And taking a look, we can see we've got all of our original rows, one for every post. We can see the post title, who wrote it, the country it came from, and how many likes the post got. So our data is now much more useful than when we first loaded it. And yep, I'm happy with that, so let's write it out to a new table, as currently our transformations only exist transiently within this pipeline. Writing the data out to a new table will store it permanently in the data warehouse. Let's write our data into a new table in our data warehouse. Let's add one more component, as we don't have an existing table to write the data to, and we need to write our data to a new table. For this, we'll need a rewrite table component. Let's give our table a new name, and we don't want this to clash with our existing posts or users table. So let's call this social media output. We can see this has been validated, and so again, we are ready to run our transformation pipeline. Running the pipeline will go step by step through our components, transforming our data and writing it out. After running the pipeline, we can go to the schemas and we can check our table has been created. And look, there it is, our social media output table now exists. And now we've built our transformation pipeline, we can run it manually after our orchestration pipeline. Let's now automate the pipeline so that the transformation runs straight after the orchestration load, and we don't have to run them both separately. And there are plenty of things you can do in an orchestration pipeline. You can use high-code options such as Python pushdown, for example. You can perform DDL tasks such as create tables and deleting tables. You can write your own SQL scripts, and you can also control the logic of how the job flows. For this example, we're going to keep it relatively simple and edit this pipeline so that it runs our transformation after loading the data. Let's pick an AND component and drag it out onto the canvas. This makes sense as we only want to transform our data once the Excel query and the Google Sheets query have finished successfully. If we hover over the component, we can see that there are three output nodes. one for failure, which is red, one that will trigger regardless, which is grey, and one for success, which is green. We want our transformation only after the success of these components, so we're going to drag the green node, meaning if both Excel and Google Sheets query components succeed in loading data, then we can move on to the next step, which will be to call our transformation job. To do this, add a new component, and the one we need is called Run Transformation. This means we can run our transformation pipeline as part of our orchestration pipeline. If we click on the properties, you'll see all of our existing pipelines, including the demo GreenWave pipelines, as well as our transformation pipeline we just created called Join Dataset. So let's select our pipeline. And if we run this orchestration job now, once it has finished loading the data, it will proceed to the AND component, and then it's time to run the transformations. The Run Transformation component will run our transformation pipeline. In the task history panel, we can see that it is all run correctly. If we go in, we can look at the task details, and it's going to tell us component by component what order they ran in, and how long it took, and how many rows have been affected. And when we get to the Run Transformation, we can explore this and see what it is doing and whether it succeeded or not. Great, now we have a load and transformation we can run whenever we like. But what if we want to run it every month or every week? Let's now create a schedule to run our pipelines automatically, so that our social media data is kept up to date without us having to manually update and run it. The first thing we have to do is commit the pipeline, because the projects run on Git branches, so you can collaborate with teams more easily and not override each other's pipelines. We're happy with the changes we've made, and we'd like to publish them ready for scheduling. So first we're going to have to commit our changes. Let's enter a commit message of social media data, let's commit the change, then push the local changes. This will give us the option to publish the branches and make it available to the scheduler as an isolated copy. This means further edits to the branches won't affect the scheduled job unless it's published. Making your schedules safer. Let's now back out into the main project screen. We can change the name and the description of the project. We can also see what type of project it is. For ours, it's a full SaaS project, all managed by Matillion, including the Git repository. It's on Snowflake, which is why we could use things like Snowflake Managed Staging in our data loading components. Under branches, we can see the branches for our project. So far, we've been working on the main branch. And at the moment, we've only got one branch. Usually you'd make a new branch to make edits or new pipelines, then merge it into the main branch when you're happy with it. But as we're just starting, and this is an example, we'll stay on main. The environment is a Snowflake environment on a Matillion-hosted agent. This was all created for us during the setup. Let's move to the Schedules tab and create a schedule for our pipelines. And let's add a new one. We're going to call it Social Media Weekly. We need to select an environment to know which database and schema to use these pipelines with. And we'll use it with our default Snowflake environment, just as before. Then we'll need to select the pipeline we want to schedule. Looking at the list, we don't want to schedule any of our GreenWave demo pipelines, we want to schedule our new pipeline. Now remember, the Join Dataset Transformation pipeline is now being called automatically by the Load Orchestration pipeline, meaning we only need to schedule our orchestration pipeline, called Load Social Media Data, as our published pipeline. Now we need to choose the time zone for our schedule. In this instance, that is London. And we'll set the frequency to every 7 days, because we want the pipeline to run weekly. Also choose a time for the schedule to run. Click Create and the schedule is created. Okay, let's do a little recap of our pipeline runs. Head up to the top left menu, go to Manage and then Pipeline Runs. Here we can see the pipelines that we've run in the last X amount of time. Now here we can see that we've run each one twice during the course of this demo. You can see the times that we ran it and also who ran it. Now we can also access the lineage for our pipelines. Click on Data Lineage, and here we can check where the data in our social media output table has come from. You can see here the columns in the tables. But where did it get these columns from? The source data is linked to the final table so that you can see the likes and post title columns came from the posts data source, whereas the username and country come from the user's data source. This T symbol represents our transformation pipeline, and its place in the lineage shows you which data it's acting on. Using the data lineage view, you can quickly look at tables in your data warehouse and understand how and where the data came from. Now let's see how we can use Gen AI to help build our transformation pipelines, all within the Data Productivity Cloud. Let's go back to our transformation pipeline and start with a quick refresher of our data. We validate the pipeline and sample the data. We have 3,000 rows of data. We can see the likes, country and username for each post. Let's now work out the total likes posts from each country have. And for this, we're going to use Copilot to help build out these transformations for us. Copilot is a generative AI that will help us build our transformation pipelines. It will change the canvas accordingly and try to fulfill our request. Let's try and be quite specific about the transformations we'd like to see being performed. Select the component you'd like to use as the basis for your new additions. Selecting a component gives Copilot a reference for the components and columns you're going to be talking about, as their names alone are not usually sufficient to uniquely identify them in longer pipelines. So we're going to select the join component. Then enter a prompt of, can I have a table where each unique country has its sum total of likes shown? Let's see what Copilot comes up with for us. We can see that it's added a new component to the canvas for us. This is an aggregate component. And if we open it up, it's grouped by country and it's aggregated the likes down by the dataset. Let's click into this and we'll see that it's chosen sum as its aggregation type, which is what we wanted. Let's sample the data. And we can see the total likes that each country has got. Okay, that looks good, it's what we wanted, but let's build on this further. Select the new aggregate component and enter a new prompt of, can you rank the countries by their number of likes? Remember, we've selected the new component so Copilot knows where to start from. So let's see what this comes up with. Okay, we've got a new rank component called rank countries, which is ranking the sum likes from the previous component. Let's check the data in the sample tab. We can see the countries ranked by total likes, with Austria ranked number 1 with the most likes. Well done, Austria. Copilot can be used instead of manually adding components to the canvas, if preferred, and all components can be edited afterwards to change the transformations. Let's add a bit of documentation to our pipeline so it's easy to understand when we next come back to it or if someone else begins working on the pipeline. For this, we're going to use the AI Note feature to create some auto documentation. Select the components you'd like to document, then right-click and choose Add Note using AI. Give that a second and documentation has been generated for each component, putting into plain English what the component is doing within the job. Click Add to add the note to the canvas. Okay, so finally, we'd like to be able to share our work with everyone else. The Data Productivity Cloud lets you export pipelines for backup or to move to different projects. Let's export our pipeline now. Click the three-dot menu next to the folder for your pipelines and click Export, which will download the pipelines as a file to your computer. If we delete the pipelines, we can see that importing them again will restore everything as expected. I'll leave a link to download this export in the description, so you can get a working version of the pipelines made in this demo, which you can import directly into your project. It means if you've had any issues following this demo, you can download this demo pipeline and import it. So there we have it. We've seen how to load data from different sources, how to transform the data and schedule these pipelines. We've taken a look at some simple options to overview your pipeline runs and data lineage, as well as how to use AI to boost your productivity. Why not try now to load your own data and see what you can create, or connect your project to your own data warehouse to start building business-ready data. For guides and help in these cases and much more, visit and subscribe to our YouTube channel, visit the documentation and Academy for written guides and courses. The descriptions for all of these will be below. And if you just want to get started with Matillion, visit matillion.com.